Okay, so we are recording. So y'all, just as a reminder, we are in week 6, y'all. And so today, y'all, we just have one section to do. It's 5.2. Y'all, the second quiz over chapters 4 and 5, that's going to open up today. I'm pretty confident it's already open. Again, y'all, 10 questions that come directly out of chapters 4 and 5.1 and 5.2. It's due a week from today, okay? And then y'all, once I'm done with 5.2, guys, what I'm going to do, I'm going to talk to y'all a little bit about test number 2, okay? I have formula sheets that I'll get to you today, and I'll set up the review for you guys and kind of let you know the way it's going to work, okay? So again, before we leave, I'll make sure that we do that, okay? So y'all, anybody need a copy of the notes for chapter 5? Let me just put them up here in case anybody needs one. Let's see. Just in case we get somebody who comes in a little bit late, that's all this. I'll put them right here like follow. So that was the little table y'all that we used the other day, and then the notes. Okie dokie, artichoke. So y'all, let's get started with 5.2. Okay, y'all. So 5.2 is this idea of called normal distributions, and we're going to be finding probabilities. Okay. So, y'all, when we were doing chapter 4, we were doing discrete probabilities. We were finding the probability of exactly 1 or exactly 2 or 3 or more, stuff like that. Chapter 5 talks about continuous probabilities, okay? And so, y'all, when we have normal distributions, and it'll tell us, and I'll talk to y'all about what a normal distribution is, but when we have normal distributions, what we can do, y'all, is we can change that to the standard normal distribution, which is what we were doing on Tuesday, where we were finding those areas, all that kind of good stuff, okay? And so what we do, y'all, is we use the formula on how to change an X value to a Z score. Because when we were here, when we were here on Tuesday, we talked about how do we find the area either to the left of the curve or to the right of the curve, all that kind of good stuff, okay? And so we're going to be applying that same principle, y'all, to the problems that we're going to be doing this afternoon in 5.2, okay? So, y'all, first thing I'm going to do here, I'm going to look at my first question, and it says, the average speed of vehicles traveling on a stretch of highway is 67 miles an hour with a standard deviation of 3.5 miles an hour. Okay, so y'all, before I do anything else, I'm going to write out a couple of things. For problem number 1, my mu, or my average, they told us was 67, and our standard deviation was 3.5 miles an hour, okay? Now, it says a vehicle is selected at random. So, y'all, there's all these cars driving down the highway, right? We pick a vehicle at random. What is the probability that it is violating the speed of 70 miles an hour, okay? So, first thing I want to do, I want to read this sentence right here. When we say that we're violating the speed of 70 miles an hour, do you think that means we're going faster than 70 or slower than 70? Faster, right? Okay. So, y'all, what they're asking me to do is what's the probability that our speed, X, is bigger than 70? Okay. So, y'all, what we're going to do here is we have this kind of normal distribution, right? So, I'm going to draw my curve. It's going to look something like this. Y'all, they told us already that our average was 67, and we had a standard deviation of 3.5. It's supposed to be a 67, sorry. And what we're trying to do is we're trying to find the probability that our speed is going to be greater than 70. So look, y'all, right here, I'm going to say, look, that's about 70. We're going to be trying to figure out what that area looks like, okay? So in order for us to do that, we're going to convert this X value to a Z score. So what we're going to do now, my friends, so I'm going to come back here. I'm going to write out my formula for changing an X value to a Z score. It's X minus mu divided by sigma. So our X number here, y'all, happens to be the number 70. So I'm going to come back this way, guys. I'm going to put a 70 minus my average, which we said was 67, and we're going to divide that by 3.5. So first thing I'm going to do, grab my calculator. 70 minus 67, it's 3. Let's divide it by 3.5. Y'all, for my Z-scores, I'm always going to go to 2 decimal places. So my question to you guys for my z-score, what do you think? 0.85 or 0.86? 0.86, right? Okay, so 0.86. Now, y'all, what we're going to do now, just like we did on Tuesday, I'm going to draw this picture here, y'all. I'm going to do my standard normal curve. If you remember, we said that the number in the middle was always 0, right? My standard deviation was 1, all that kind of stuff. What I'm going to do now, y'all, I'm going to come over here and I'm going to look for 0.86. I know that's just to the right of 0. And what we're trying to do, y'all, we're trying to find the area underneath this curve. Now, y'all, if you remember from Tuesday, when we would go all the way to the left, all the way over here, remember John said, why don't we use like 500? I'm going to go 5,000, John, just to go a little bit, just to be a little bit more, okay? And on this side, y'all, we're going to go positive 5,000. So, y'all, if I'm trying to find the area all the way to the right, okay? If I'm trying to find the area all the way to the right, remember, y'all, this is when I'm going to go to my calculator and I go to my normal CDF, okay? Where are we going to start shading? Where do we start at? What's my starting point here? Anybody know? 0.86, right? Good, 0.86. And where do we end? When do we stop going? What number are we going to use for our stop, our ending number? 5,000, right? Okay. So check this out, y'all. I'm going to come back here. I'm going to grab my calculator. Boom. Let me turn this guy on. There it is. Let's clear it. We're going to go second bars. We're going to go to number 2, our normal CDF. We said we were starting at 0.86, comma, and we're going to go all the way all to 5,000. Okay. There we go. And let's hit enter. And again, y'all, we're looking for this area, right? So y'all, when we're looking for this area, remember, we're going to, with the probability parts, y'all, with my answers here, I'm going to be going to 4 decimal places. So if I go to 4 decimal places, would you guys say 0.1948 or 1949? 1949, right? So what's the probability that a car that we pick has a speed greater than 70 miles an hour? It's 0.1949, okay? What we're trying to do here, y'all, is because it has a normal distribution, the curve is going to be that bell-shaped curve, okay? And we're going to have our average and we'll have our standard deviation. What we're going to do, y'all, we're going to convert that to the standard normal distribution, which is what we were doing on Tuesday. And once we have that, then we can find the probability, okay? So for every one of these questions, y'all, my process is going to be the same, okay? Now, let's come back over here and let's take a look, y'all, at question number 2. Okay, so look what it says, y'all. Question number 2 says, the monthly utility bills in a city are normally distributed with a mean of 100 and a standard deviation of 12. Okay, so y'all, first thing I'm going to do, I'm going to just draw a very simple picture. This is not a Picasso by any means, okay? Very simple picture. Look what they tell me the mean was. The mean was 100. So right here, y'all, my mean is 100. And my standard deviation, right about here, that number, y'all, my sigma is a 12, okay? Now, for part A, y'all, for part A, they're me, oops, sorry. Let me get rid of my email, guys, because it'll keep dinging. Sorry about that. Let's come back this way. Boom. All right. So the first part, y'all, they're asking me, what's the probability that the utility bill is less than 70? So y'all, I'm going to come back over here. I'm going to say, look, right about here is 70, and we're going to be looking for that area, okay? What we're going to do first, y'all, is we're going to convert this so we can use our standard normal distribution. So my step number 1, y'all, okay, my X number is 70, and I'm going to use my formula to find my z-score, okay? So we're going to take 70 minus our average. Remember what we said our average was? Our average was 100. We're going to divide that by our standard deviation. Remember we said our standard deviation, y'all, was 12, okay? So y'all, I'm going to grab my calculator over here, and I'm going to say, what's 70 minus 100? Should be negative 30. Very good. Let's divide that by 12. Again, y'all, with my z-scores, I'm always going to go to 2 decimal places. In this case, negative 2.5. You want to write negative 2.50, that's fine too. Okay. Now, what I'm going to do now, y'all, I'm going to draw a new picture. Here's my normal curve. My average in the normal curve is always 0. My standard deviations is always going to be 1. And y'all, we're trying to find what's the probability that we're going to be less than, in this case, negative 2.50. So look, y'all, if I come back over here, right about here, my friends, negative 2.50. So remember, y'all, I'm looking for my area to the left. We did this a minute ago. If we were to continue going all the way to the left over here, what would the number we would put on this side be? Negative 5,000, right? Okay. So now, y'all, we're going to do the same thing we did before. Sorry, I should have put more space on these problems. Y'all. I apologize about that. So look, y'all, we're going to go with our normal CDF. Okay. Where do we begin to shade? Anybody know? Negative 5,000, right? Okay. And we stop at what number? Negative 2.50, right? Guys, does that make sense? If I look at my picture and we said, look, we're going to go less than 2.50, so we're going that way, right? So where are we starting? We're really starting at negative infinity, but we can't plug in negative infinity, right? So we're just using a really, really small negative number, like negative 5,000. And then when do we end? At negative 2.50, right? So again, y'all, when I come back over here and I say, look, let me grab my calculator again. Let me turn it on. Okay. I'm just going to go second enter. And again, y'all, I'll come back this way. We said negative 5,000, right? 1, 2, 3, comma, and we went to negative 2.50 or negative 2.5, didn't really matter, right? And again, y'all, with my probabilities, they're always going to tell me to go to 4 decimal places. So what do y'all think? 0.0062, right? So 0.0062. And there's our probability, right? So that's a pretty small probability, right? That's not even, okay, and then just hit enter. Keep hitting enter. Let's see, second enter. You know why? Negative 2.50. Oh. You got positive. Yeah. Okay, y'all, if I look at the next problem, look what it's telling me. Find the probability that my utility bill is between 90 and 120. Okay, so look, y'all, first thing again I'm going to do here, I'm going to come back here and I say, look, we're looking for the probability that our utility bill is between $90 and $120. Y'all, if I were to come back, again, draw a very basic picture, right? We said our average was 100, and now we're looking at 90 and 120. We're kind of looking for that piece right there, right? So again, the first thing I'm going to do, y'all, I'm going to convert those two values to z-scores, okay? So y'all, I'm going to do it like this. I'm going to say the first one, x1. I'm just going to call it x1 because I got two values. I'm going to call that 90. And I'm going to call my x2, y'all, 120. And I'm going to find here, y'all, I'm going to find two z-scores, okay? So the first one, my friends, I'm going to call it z1. And I'm going to take 90 minus 100 divided by our standard deviation, which we said was 12. Okay. So let me get my calculator. Here we go. 90 minus 100, boom, divided by 12, negative 0.83. Okay. Negative 0.83. Let's find our second z-score. Y'all, we're now going to take 120 minus 90 and divide it by 12. So 120 minus 90, and let's divide this guy by 12, 2.5. Okay. Again, y'all, I apologize for not putting enough space here, y'all. That was my bad. Here's my normal curve, right? Here's 0. In the standard normal curve, y'all, my mean is always going to be 0. We're looking now, y'all, for the area right here, negative 0.83. Sorry about that. negative 0.83, all the way to 2.5. Okay. So again, y'all, first thing I'm going to do, I'm going to go normal CDF. Okay. Where do we start shading here, y'all? What do you guys think? Where do we begin to shade in this picture? Negative 0.83, right? All the way, my friends, to 2.5. And y'all, this is how I'm going to find my values, okay? So I'm going to go second vars. We're going to go down to number 2, normal CDF. We're going to set negative 0.83. And then we're going to go comma, 2.5. Close it off, hit enter. And y'all, I'm coming up with 0.7905, right? So the probability that we have a light bill or utility bill between those two values was 0.7905. Because it told me right here that my average was 100. That's it? Yeah? Yeah. That's where we're getting that from, right? So again, that was why in my first picture up here, we notice right here, remember we wrote our mu is 100 and our sigma was 12, right? So look, y'all, there's a part C. Guys, I'm going to kind of do this on the side again. I apologize for not giving y'all enough space here, but I'm going to do part C, y'all, over here to the side. So look, it says, can we find the probability that our bill is more than 140? So again, y'all, I'm just trying to give you guys a visual of what's going on here. We're looking for the probability that our bill is more than 140. Remember, my regular picture, y'all, looks something like this with 100. And since my standard deviation was 12, right, those were 12 over here. So this would be like 112. And this looks like it'd probably be like 88, right? Okay, now we're trying to figure out what's the probability that my bill is going to be greater than 140. Y'all, 140 would be somewhere over here, right? So what we're going to first do, my friends, is we're going to come back and we're going to change the 140 to a z-score. So we can use that standard normal distribution, okay? So y'all, I'm going to take 140 minus 100, and again, we're going to divide it by 12. So we all know that 140 minus 100 is just 40. Let's divide that guy by 12. And y'all, I'm coming up with 3.33, okay? Again, to give you the visual, y'all, of what's going on. Remember, here's my 0, here's 1, here's 2, here's 3. We are looking for, y'all, 3.33. And we're going to go all the way to the right. So, y'all, if we're going to start at 3.33 and we're going to go all the way to the right, what number would we put over here? Anybody know? 5,000. Very good. Okay. Now, again, y'all, I'm going to go with my normal CDF. And we're going to start at 3.33. And we're going to go all the way, y'all, to 5,000. Now, y'all, remember, I was telling you guys this on Tuesday. You can use your table if you want to. I don't know. Does anybody find using the table? I'm sorry. Does anybody find using the table easier, or do you think it's easier to use a calculator? Anybody got an opinion? Calculator is a lot easier, right? Okay. So again, y'all, and I'll show you if you wanted to use the table, guys. I'll show you how you could do that right now. But look, I'm going to go normal CDF, 3.33, comma 5,000, right? Boom. Let's go like this. It's going to be a really tiny number. Whoa, look at all that, y'all. Guys, let me give you a heads up. When you see something like this, y'all, let me write it out here for us. It was like 4.34, I'm going to say 29, right? But then it had this e to the -4, didn't it? Okay. Y'all, what that means, this is scientific notation. What this means is that I'm going to take my decimal point, y'all, and I'm going to go 4 spaces to the left. 1, so right in front of the 4, 2, 3, 4. So y'all, we would have something like this. It would be 0.00, I guess 4 if we're going to go to 4 decimal places because that number there is a 3. That's what that number means, okay? So if my calculator gives me that e to the negative, it just means you're going to take your decimal point, guys. You're going to move that number of spaces to your left. Okay. Now, again, y'all, if you prefer using the table, the one thing I want to emphasize about the table, my friends, the table always tells you the area to the left. Okay. The table always tells you the area this way. So if you were going to do this, you would really be finding the area over here. And if I was going to do that, let me see if I can do it with my table here. Boom. Okay, I'm going to go to my positive values. Here we go. I'm looking for 3.33. So let me zoom in just a little bit, see if I can do this. There we go. So look, y'all, sorry, I know it keeps doing this thing. And I guess unless I move that out of the way. Oh, come on. Well, look, I think this was 0. Yeah. So 3.33 would have been this number right here, that 0.9996. So that would have told me, y'all, that this area right here would have been 0.9996. So if I was really looking for that area, I would take 1 minus 0.9996, and there is my answer, right? And that's the same number that we got, okay? So again, I just want to show you, can you use the table? You absolutely can. The one thing I really want to emphasize, y'all, about the table is that table always tells you the area to the left. So if you're trying to find the area to the right, once you find the area to the left, you're going to take 1 minus that, okay? So again, it's really up to you. I personally think the calculator is easier to do it, especially the way we draw the pictures. You can see what's my first number, what's my second number. I think it's easier. But again, I've had students before that are like, sir, I don't know. I'm old school. I use the table. By all means, use it. Okay. Okay. Y'all, let me scroll down a little bit further. Again, similar questions here, y'all. Similar questions. Let's take a look. It says a Toyota Camry. It says braking distance on a wet surface is normally distributed with an average of 149 feet and a standard deviation of 5.25. Okay, so y'all, first thing I'm going to do here, before I do anything else, I'm going to say, look, my average or my mean is 149, and my sigma is 5.28. Okay. The question is asking us, can we find the probability that a randomly picked Toyota Camry has a braking distance between 140 and 149? Okay, that's what we're trying to find. So y'all, we actually have 2 X values here, okay, just like we did before. My friends, I'm going to call this my X1 and I'm going to call this my X2, okay? And we're going to find 2 Z-scores, y'all. So again, just as a reminder, y'all, the formula for the Z-score is X minus mu divided by sigma. So y'all, I'm going to find what I'm calling my first Z-score, and I'm going to take 140 minus 149 divided by 5.28. So let me grab my calculator. 140 minus 149 divided by 5.28. Okay, remember, y'all, we're going to be going to 2 decimal places. Every time I do my Z-scores, 2, my answers, or my probabilities, y'all, always going to be 4. Negative 1.7? Okay, good. Or 1.70. You can just write 1.7. That's fine, too. All right, look, y'all, let's do the same thing. Let's find our second one. So we're going to take, what is that, 149 minus 149 all over 5.28. Everybody agree that's got to be 0? Okay. So now, my friends, I'm going to come back here. I'm going to draw my picture. Boom, here it is. Remember, y'all, in my standard normal distribution, my mean is going to be 0, right? Let's take a look at where we're trying to find the area between. We're trying to find the area, y'all, between negative 1.70 and our second one, which was 0, right? We're really looking for this. So we're going to see if we can find that area right there, right? Again, y'all, I'm going to grab my calculator. I'm going to turn this guy on. Let's clear it out. Let's go second vars. Let's go to our normal CDF. We start at negative 1.70. Boom, boom, here. And we stop, my friends, at 0, right? Boom, there you go. We'll find our probability. And y'all, I'm coming up with 0.4554. So our probability, y'all, 0.4554. Question, y'all. On a level of 1 to 10, 1 being like, hey, Omar, I got no idea what you're doing up here. And 10 being like, papas, easy breezy cover girl. How do you guys feel about 5.2 so far? 8, 4, 3, 9. Anybody? 5, 2. Okay, guys, let's do a few more. Again, my goal, y'all, is when we leave for the day, I want you guys to feel like at an 8 or above. Okay. And y'all, if I'm doing something up here and you're like, I don't know what you're doing, tell me, guys. I want to make sure that you guys are good. Okay. But what is your second number?
My second number is, so it's negative 1.70, and then my second number is 0, 0, and then 100.
Not 100, just 1.
There it is.
Yeah.
Why don't you put 1 point more at the bottom too? Or like times 2.
Remember, what's my formula? My formula, right, is x minus mu over sigma, right? So my x number here was what number? 149, right? What's my mu number? 149, right? You see what I'm doing? Yeah. Okay. So y'all, I got a couple more questions. Again, let's make sure that we're good here, y'all. So let's take a look at this next question. And it says, look, using the chart above, find the probability that a member selected at random will have a cholesterol level between 220 and 255 milligrams per deciliter. So y'all, look, they gave us a picture here. They drew the picture, the same kind of pictures we've been drawing. Okay. So y'all, what we're trying to do in part A is we're looking for the probability that a person's cholesterol is going to be between 220 and 255, right? Y'all, this problem, I'm going to do this problem very similarly to the way we did the one before, okay? So y'all, my first step, I'm going to call this my X1. I'm going to call this my X2. Y'all, we already have our average and our standard deviation, okay? So remember, y'all, my formula says we're going to take X minus mu divided by sigma, right? So the first thing we're going to do, y'all, we're going to find our 2 z-scores. So I'm going to call it Z1, okay? So we're going to take the first X score, 220, minus our average, which they told us up here, y'all, was 205. And we're going to divide that by 37.8, okay? So let's go 220 minus 205. Let's divide that by 37.8. And y'all, if I go to 2 decimal places, would you guys say 0.39 or 0.40? 0.40, very good. 0.40, excellent, y'all. Let's do our second z-score, okay? Our second z-score. Y'all, we're going to take our X2, which in this case was 255, sorry. 255 minus 205 and divide it by 37.8. So let's do this. 255 minus 205 divided by 37.8. What do y'all think? 1.32, 1.33? 1.32, excellent. Okay, now y'all, just to give you a visual, in my standard normal distribution, my average is 0. My standard deviation is 1. Look where we're going to start at. We're looking now, the probability that our z-score is between 40 and 1.32. So right here, y'all, 0.40, somewhere over here, 1.32. That's the area right there, y'all, that we're looking for, okay? Y'all, I'm going to use my calculator again. I'm going to turn this guy on. Let's clear it out. We're going to go second vars, okay? Normal CDF. Y'all, the only thing you're doing is putting in the 0.40 and the 1.32. You're not changing the mu. You're not changing your standard deviation, okay? So we're going to go 0.40. Oops, sorry. Number 2, 0.40, comma, 1.32. And is anybody coming up with 0.25, I guess 12? Right? We're all getting the same thing, 0.25, 12? Okay, awesome. So look, y'all, our probability that this is going to happen is 0.2512, okay? Now, y'all, I want you to think about that. If we were to think about that number as a percent, if I was thinking about that number as a percent, y'all, that would just mean 25.12%. So about 1/4 of the people are going to have a cholesterol in this range, okay? Now, there is a part B to this question, y'all. Part B to this question says, if there were 350 people or 350 men in that age group, how many of them would we expect to have a cholesterol greater than 260? Okay, so y'all, let's see if we can figure this part out. First thing I'm going to do, we're looking for the probability that their cholesterol is bigger than 260. Okay, so again, y'all, let's find our z-score. Let's go z equals x minus mu over sigma. In this case, my friends, my x is 260. Remember, our standard deviation and our average are still up here. That's still 205, and that's still 37.8. So 260 minus 205 divided by 37.8. Y'all, my z-score, what do you think? 1.45 or 1.46? 1.46, right? Okay, remember what we're trying to find now, y'all. What's the probability that z is greater than 1.46? If I were to draw my picture, y'all, here's 0, boom, here's 1.46. We're looking for the probability to be more than that, which means we're going to the right, okay? Okay, so y'all, if I'm going to find that probability of going to the right, everybody agree we're going to start at 1.46? Okay, and we're going to end at what number, y'all? 5,000, right? So look, y'all, 1.46, comma, we're going to go all the way to 5,000, right? We're going to close that off. We're going to hit enter. And y'all, the area that we're coming up with is 0.0721. Okay, that's the probability. Now, one thing I want to mention, y'all, before I go on, this question, we had to do this. We needed to find the probability. But now they're telling us if there were 350 men in this age group, how many of them would have that cholesterol range or greater than 260? What we need to do now, y'all, we need to multiply 350 times that 0.0721. Okay, and that's going to tell us exactly the number of people who are going to have this cholesterol. So I'm going to multiply that by, we said what, 350, because that's how many people we were looking at. Y'all, here we're going to go ahead and round to the nearest whole number. How many men would have this cholesterol? 25, right? So how many people are going to have a cholesterol greater than that? 25 out of the 350. Okay. Y'all, I want you to notice something as I'm going through these questions, like as we did this one here. Obviously, this is a question, y'all, for those of you who are going into health sciences, these are some of the questions you'll see in some of those courses, okay? So again, one thing I want to emphasize is that, y'all, I'm not just finding probabilities for the sake of finding probabilities. The one thing I've always appreciated about this class is that I feel like this class has a lot of applications to both health sciences, y'all, and social sciences, okay? So, y'all, I think I got just a couple more questions to do. Yeah, here we go. Y'all, this is a question. I actually found this question, y'all, out of a different textbook, but I thought it was kind of, again, for those of you who are going into health sciences, nursing, things like that, I just thought this was kind of a neat question, okay? So let's see if we can figure out what's going on here, y'all. It says, according to a statistical journal, the average length of newborn babies is 19.1 inches, okay? So I'm going to write a couple of things down. Remember, y'all, my average is 19.1 with a standard deviation of 0.9. Okay, you've seen newborn babies. Oh my God, how cute are they, right? They're like this, they're tiny, right? They're all waddled up. Okay, so we're talking about the length of a baby, right? The distribution is approximately normal using technology or a table. Answer questions parts A through C below. Okay, y'all, I'm going to zoom in here and we're going to pick our graph, okay? So for part A, y'all, there's going to be two parts. We're going to find the probability, but we're going to pick our graph first. What's the probability that a newborn baby is going to have a length of 18 inches or less? Okay, so y'all, first thing I want to do all of these graphs have an average of 19.1? Meaning, is the number in the middle 19.1 on all of them? Yeah, okay, so that's not going to help me out too much. Okay, but we are looking for the probability that the baby is going to have a length of 18 or less. So we're looking for smaller than 18. Y'all, I want you to look at these graphs here, okay? Which one of those graphs looks like we're shading everything from 18 to the left? D. Does that make sense? Okay, so let's pick D, and you know what's going to happen, right? When you're doing this on your Pearson, you're going, boom, good job, right? Or excellent, whatever. Okay, now let's see if we can find what that probability is. All right, y'all, first thing we're going to do, we're going to convert that number to a z-score. So the number that we're looking at here, y'all, 18 minus 19.1 divided by 0.9. Okie dokie, artichokes. 18 minus 19.1 negative 1.1 divided by 0.9, negative 1.22. All right. Okay, now y'all, I'm going to draw a picture right here. I'm just going to do it in the middle. Remember, here's my 0, right? Because my standard normal one always has 0 there. 1.22 on the negative side over here. Remember, y'all, we're shading to the left. What number would we have put this way? All the way this way? Further. Remember, we're in my regular one. If I'm all the way to the left, what number we're going to use over here? Negative 5,000, right? Okay. So look, y'all, we're going to come back here. We're going to go second vars number 2, negative 5,000. 1, 2, 3, comma, negative 1.22, right? Don't forget your signs, y'all, because it'll mess it all up. Okay. Now, is anybody getting 0.11, 0.12? Okay. Now, guys, I want you to notice something here. They're asking me to write this as a percent. Remember, y'all, as a percent, all I'm going to do, I'm going to take my decimal point and I'm going to move it 2 spaces to the right. And so if I move it 2 spaces to the right, would you guys agree we'd get something like 11.12%? Okay, but just one last little thing here. They're only asking me to go to 1 decimal place. What do you think, 11.1 or 11.2? 11.1. Boom, and you got it. Take it away. Sound good? Okie dokie, artichokes.
So, and is there anything like that we could see in the graph that actually, like, for example, you know how he points out 18 right away, right? Can we see that? We can really say, hey, that's the answer.
That's right? So look, hold on. So before you do that, look at part B. Look at part B, y'all. It says, what percentage of newborn babies would be longer than 20 inches? Does longer mean less than or greater than? Greater than 20. Okay, so again, y'all, remember, all of my averages here, 19.1. Which one says we want to go from 20 to the right? D again, right? Boom. Is it always going to be D? I don't know. I don't think so. That'd be kind of silly, but who knows? All right, right? So we're going to go boom right here. Y'all, just like we did a minute ago, remember what we said? Our average was 19.1. Our standard deviation was 0.9. My X value here is 20. We're going to convert that, my friends, to a z-score. So we're going to go 20 minus 19.1 divided by 0.9. Okay. So let's do that. 20 minus 19.1. Boom. Divided by 0.9. Y'all getting one? Anybody else getting one? Yeah. Okay. Okay. So look, y'all, let's draw a real simple picture. Boom. Here we go. Remember, the number in the middle, y'all, is 0. We're going to go from 1 all the way to the right. Remember, over here, everybody agree 5,000? Okay. So let's try that again. Let's come back here. Let's go second bars. Let's go to our normal CDF. We're starting at 1. And we end where, my friends? 5,000. Boom. Let's go like this. Let's hit enter. Again, y'all, remember, we're going to change it to a percent, and then we're going to round it to 1 decimal place. So, y'all, if I were to change that number to a percent, everybody agree 15.86%, right? Or 87, whatever you want to call it. Okay, so let's say 87. But now they are only asking me to go to 1 decimal place. Would you guys say 15.8 or 15.9? 15.9. Boom. And you got it. Did that answer your question, though, about what you were saying, like with the greater than?
No, I was going to ask, is there anything like, how we see right away, like a 20? We can guess it's, we know it's D, right?
Uh-huh.
Anything with like 15.9 that we can see on there that, like, you know what I mean? To know the other?
No, because I have to do the math to get that 15.9. Yeah. Okay, so y'all, there's a part C to this question. This is the last part here. Now, let's take a look, y'all. It says baby clothes are sold in a newborn size that fits infants, between 18 and 20.4 inches long. What percentage of newborns will not fit into these sizes? Okay, so y'all, first thing they're telling me is that if we were to go buy newborn clothes, right, those newborn clothes fit babies who are between 18 and 20.4 inches long, right? That's what the newborn clothes fit. But we're looking for the ones who don't fit. Would they be within those ranges, or would they be outside of those ranges? Outside of those ranges. Okay, so y'all, let me ask you a question. Which one of those is looking at outside of those ranges? A. Does that make sense?
Yeah.
So this would be the ones that do fit, but the question says, will what? Will not fit, right? So guys, I gotta be careless here, right? So I'm reading through it, I kind of say, okay, this is it. This is would fit, but we're looking for the ones that don't, right? So wouldn't we pick choice A again? Boom, there we go. Okay, now, last thing, guys, we need to find that percentage. Now, remember what we said. When we have a normal distribution, the area under the curve, y'all, is always going to be 1. Let's do it like this, my friends. Let's call this our X1 and let's call this our X2, just like we've been doing. And let's find our Z-scores for those. So my first Z-score, y'all, will be 18 minus 19.1 divided by 0.9, right? Oops. Okay, let's come back here. 18 minus 19.1 divided by 0.9, negative 1.22, right? Okay. Our second Z-score should be 20.4 minus 19.1 divided by 0.9. Let's see. Divided by 0.9. Boom. My second Z-score, y'all, 1.44? Okay. So again, y'all, I want to kind of show you something here. If we were doing our standard normal distribution, remember this number here, y'all, is 0, right? We could say, look, let's do this. 1.22 over here, y'all, 1.44. We really want to know the outside, okay? But what we could do, y'all, let's find the area inside first, okay? So y'all, I know I'm looking for the area outside, but let's find the area inside first. Do you guys agree? Second bars, normal CDF, we start at negative 1.22. and we end at 1 point, what, 44? Good. Okay, y'all, this would tell me the area inside, which is 0.8138. 0.8138. Now, because we want to find the area on the outside and the total area is 1, the way we're going to find the purple area, we're going to take 1 minus 0.8138. So 1 minus 0.8138. And y'all, I'm coming up with 0.1862. Okay. And again, y'all, we're going to go to 1 decimal place. Would you guys say 18.6 or 18.7? 18.6. Boom. Did that make sense, y'all? Yes, tell me.
You did the -1 because they said it will not
Because
fit.
we were looking for the area that it's not going to fit. So we said, well, let's find the probability that it does, and then the way we find the probability it doesn't, it's always 1 minus that. Remember, guys, I said on the first, well, not the first day of school, but when we started talking about probabilities, I said, hey, if Tim Smith tells you there's a 65% chance it's going to rain, what's the percent chance that it's not? We would say 35. Why? It's 100 minus 65. So like 1 minus 0.65, 0.35. Same sort of idea here. Guys, let me ask you one last question before I talk about test 2. On a level of 1 to 10, how do you guys feel about 5.2 now? What do you think? 1 being like, sir, no entiendo nada. 10 being like, papas, easy breezy, cover girl. What do you guys think? 8? Better? Feeling better about it? Guys, I know this is the first time a lot of us are seeing this, okay? What I want to point out, guys, is that the process and how I was doing this was very much the same. And I think one thing I liked about this question, hey, it's newborn babies. Everybody loves newborn babies, right? But again, it also shows the applications to healthcare and stuff like that, okay? So y'all, before I do anything else, I'm going to come back over here.
Do we still work next Sunday?
Well, I mean, the homework, right? The homework is your practice, right? So guys, the other thing I want to mention, boom, let's go like this. And let me come back over here and let me post this. Okay, so y'all, an announcement just went out regarding test number 2. Okay, so y'all, let me give you some info. This is the same thing that went out in the announcements. Okay, so let's see. Begin working on the review for test number 2. Guys, the review is already set up for you. If it isn't open right now, I'll make sure it's open right now, okay? 44 questions. Y'all, every question out of the review came out of 4.1, 4.2, 4.3, 5.1, 5.2, which we just did. And next week, guys, we're going to do 5.3 and 5.4, okay? Every question, when you see it on the review, if you've been doing your homework, this is the second time you're seeing that same question, okay? Not this coming Tuesday, but the following Tuesday. That day, guys, we'll do a little Kahoot review again. Any questions you guys might have out of the review, happy to answer them, all that kind of good stuff, okay? The review, it does not have 4 questions. The review has 44 questions. Sorry, I put there has 4. Test, guys, the test has 18 questions. I picked those 18 directly out of the 44. So again, if you've done the homework and you do the review, by the time you get to test 2, this is the 3rd time you've seen that same question, okay? Those questions, guys, came directly out of the review. On the 11th, it's going to open up at 4 o'clock. It is due on the 25th. Y'all, the 25th is when we come back from spring break. I mentioned this on Tuesday, but I want to sort of reiterate it again. So let me come back over here. Y'all, spring break is the week of the 17th through the 23rd. I want to make it perfectly clear. I do not expect you to do anything school-related between the 17th and the 23rd. The test is open on the 11th. You can take it on the 11th, on the 12th, on the 13th, whatever. It is due on the 25th. If guys, you're keeping up with the homework and you start working on the review and you're feeling good about it, I would do it sooner than later, because I'm not saying that you're going to be out partying and doing all this stuff. I know everybody's got jobs and all this kind of stuff, but I would not want that on the back of my mind, okay? Guys, you have 5 hours for the test. You have 2 shots for the test, okay? If you're happy with the grade the first time, you don't need to do it again. I will take the better of the 2 averages. On the 13th, which is the Thursday before spring break, we do not have class. That's me giving you the day to take your test. If you say, Omar, I'm really busy. I don't have time outside of class. Take it on the 13th. I'm giving you the day off so you can do it. Okay. What can you use for the test? Guys, you can use your notes. I have a formula sheet right here, and I have copies, and I'll get that to you before you leave for the day. So y'all, I have the binomial, the Poisson, right, all this kind of stuff, Z-score, right? How do I do these things on my calculator? We're going to talk about this starting next week, okay? But I got all that kind of good stuff there. What can you not use? Guys, no photomath, no goth, nothing like that. Can't work together, whatever else. Make sure that your work is your own work. I'm okay you using YouTube videos that we made, right? All that kind of stuff. What I'm not okay with you guys doing is having somebody else help you with it, going to ChatGPT. I'm going to give you one too, this one. Any of that other stuff. And guys, I want to make that perfectly clear. What I'm trying to do, y'all, by allowing you to do this on your own, my intention, guys, is to eliminate a factor of time so that as you are going through the test, I don't want you to, if you were taking it on, say, that Thursday, class starts at 2, it's over at 3:45. I would not want it to be 3:30 and you're sitting there thinking, I still have 4 questions to do and I got 15 minutes and you're getting nervous. I'm trying to take out that factor of time, okay? So again, I'm telling you, I'm doing this on the honor system, right? I'm assuming that you guys are going to sit down, have your notes, have the videos there, right? Looking at your formulas, going back and watch, and being able to replicate what we did. We just finished test 1 the other day, and there was 2 people who cheated on the exam, and they were in the find out situation of the FAFO. You guys know what I'm talking about? You heard the expression? Okay. Those 2 people have been withdrawn from the class. I hate having to go through that, right? I hate having to do that because it's not a pleasure of mine. I don't like having to tell somebody, hey, didn't I tell you not to do this? Yeah, what'd you do? I did it anyway, right? We're adults, right? We're all grown people. So guys, if you cheated on test 1 and I did not catch you, think of that as your get out of jail free card, like Monopoly, okay? Maybe you lucked out, but please don't do it on test 2 or 3 or 4 or whatever, because if I do catch you, I'd hate for you, like, man, I've spent half the semester in the class, and now I gotta go withdraw, right? And what I tell those people is, you know what? Whenever you come back and you take statistics again, find somebody else to take it with, because then I have to change how I do things, right? Because if that person comes back, I can't trust you. And you've heard that expression, this is why we can't have nice things. I don't want to penalize everybody else because we have 1 or 2 people who are being, excuse my language, dumbasses, right? That's what you're really being. You're being a dumbass and you're fucking everything up for everybody. Sorry. But I don't want to have to change all that stuff, okay? So again, y'all, please do me a favor. Use your notes, use the YouTube videos, right? Go back on the day that we're going to review, come with your questions so that we can get all that stuff cleared up. But don't try to go for the easy way out because it never works, okay? It never works, all right? Anyway, guys, that is it for us today. That was 5.2. Next week, my friends, we're going to continue with chapter 5. We got 2 more sections to do. I hope chapter 5, guys, is feeling a little bit easier, a little bit less stressful. That's sort of the intention. Chapter 5 is kind of like, wow, it's a little bit of a break. Finding the areas, not a difficult task to do. You just kind of have to figure out, what are my limits, right? What's my lower bound and my upper bound, okay? Anyway, guys, that is it for us today. Thank you all for showing up. I appreciate it. If anybody has questions, guys, please let me know. I'm happy to answer them. And I'll make sure that, guys, that the review is open for you guys, okay? I'm going to stop recording, y'all. Boom, boom, boom. And